We'll see how the sound is.
So I think it might be.
Yeah. Can we have that picture up there? Steady? Oh, it doesn't stream.
Yeah, I think it
Yeah.
is. I'll check on the...
Data, this is Log. Can you call out if we go beyond 2.5 bars? Can do. We are currently at 2.3. Understood, thank you.
Ja.
Linket til vores livestream op på Slack, så de andre også kan finde den og følge med.
Yeah, can you do that?
Yeah.
Yeah, thank you. Well, are we here online?
Yeah, well,
Well, welcome to our live stream. We have had a bit of problems here with the setup. Connection to the camera was a bit off. So, but now we are running and we are quite far into the checklist, and we are, as far as I remember, we are just loading, pressurizing the tanks right now. I'll just check up on the checklist and see. But basically, we are today testing. This is the second test of our liquid nitrogen evaporator system, where we are testing a tiny rocket engine that basically is, we call it a hair dryer on steroids, because the output of it corresponds to 300 common hair dryers. It's producing a lot of hot gas we will use for boiling and pressurizing, heating up nitrogen, so we can pressurize our tanks with that. But last time, it was a few weeks ago, we tested it with an electric spark igniter, and it didn't really work very well. And now we're trying with glow plugs, actually from a common diesel car, and we've had some experiments with it, and it looked promising. So that's what we're going for right now, and I will just check up on the checklist and see how far we have gone with that. Just a second.
Status logs. Pressure has now dropped to 1.7 bar. Okay, understood. I will open up side data. Roger that.
Yes. We have, do you know what number we have reached now on the checklist? I have the checklist up on the second screen, and I can, I'll try to see how far we've gone. I can't find my mouse. It has gone away. Oh, that popped up. On the cameras, you have 4 views here. The top left is 51.
Yeah.
51. Let's see. It's black. Yeah, it's a LOX loading process we are going through. Up on the top left, you can see the great area we're at here. It's an old BMD shipyard, which is empty now since the 80s, and we are testing. We have our container there sitting in the middle of the area, on a distance to everything that can be heard. and on the right top corner you see a view from inside the test container, where you can see the tiny heat generator, the bourbonizer, or what you would call it, the little rocket engine we are testing. And on the bottom left you can see the mission control in a darkened pavilion, where we have the data people and the fire extinction control and so on. And here on the bottom left you can see me, it's Jørgen, who has promised to take care of this live stream today. And you are of course welcome to ask questions in the chat, and I have help from my assistant Bianca, who will try to keep me updated on questions, because I have a bit difficulty looking over there to that and see what is happening there. So she will try to remind me if there's interesting questions I have to ask. So we're just listening now to the chatter on the radio, where you can hear both the mission control and the crowd control talking on the same channel today. But as I told earlier, we have reached point 51 out of, yeah, I think it's 64 before things are really going to happen. 51 is load locks, and they are working on that. Yes, you are welcome to mention if there's anything that's weird, like the sound, or any suggestions. Please tell me in the chat.
Data, this is locked. Can I get a reading on the loading pressure? Yeah, the loading pressure is still 1.3 bars. Understood, I'll open up now then. Roger that.
Just tune up the radio so I'm sure you can hear what they're talking about. As you know, Copenhagen Suborbitals is working on a big new rocket construction. It's way bigger than the ones we have built before. The latest launches was the Nexus 1 and 2.
Data, this is locked. Can I get a reading again?
That was
Yeah,
Nexus.
pressure has increased to 1.5.
They are
Okay, understood. I'll increase again then.
okay. They are loading locks, and it takes quite a while in the beginning, because the liquid oxygen is minus 183 degrees centigrade, and when you pour it into a tank at ambient temperature, it will simply boil really wildly, and until the temperature has dropped to
Loading pressure is now 2.3 bars.
to the boiling point of liquid oxygen. So it can take some time before it's fully loaded, and the pressure can rise as we want it.
It seems like the LOX level has reached the sensor. We are now measuring 25 liters.
Okay, already 25 liters in the tank. That's interesting. We have got from Air Liquide, we got delivered 190 liters of liquid oxygen, and it has been standing at our workshop a couple of days, boiling, releasing a bit of oxygen all the time, and we were a bit afraid that when we have this very hot weather in Denmark, that we would lose too much of the liquid oxygen.
The level is reading 30 liters now.
Yeah, we are actually just loading around 30 liters of liquid oxygen into the tank, but during the test we probably won't use more than 2 2 or 4 kilograms of liquid oxygen. So it's a bit overkill maybe to buy 190 kilograms or liters, it is actually, in a tank just for this, just to be able to use 2 or 4 liters. But that's necessary because the liquid oxygen has to be standing in a thermal flask. It's called a debrief bottle, where which is insulated like a thermos flask, and it's standing there, keeping itself cool by boiling all the time. And that's why we had to buy 190 liters just to be able to use a few liters during the test. We are still at point 51. When we're reaching point 64, it says pressurized tanks and fire when ready. It is written with red in the test plan, so we know that's seriously. So that's serious.
Can you confirm the loaded amount of liquid oxygen, please?
Can people out there hear it?
The is fluctuating between 31.5 and 32 liters. This is fine. We have closed down locks, loading, and vented all lines. Step 51 completed. We're loaded.
Yeah, we can hear the
We have loaded. Can they hear this? Is it? Yeah.
All right, we are very close to a test firing. Step number 53. Video, please start your high-speed
Yeah,
cameras.
okay.
Confirm when complete.
55 now, initiating pressurization and firing sequence. It's a bit fun to look at the test plan. I was going through it late last night, and I found points here and there we should have changed. It's actually a reuse of old test plans. We have these long test plans. In this case it's only 2 pages, but we are of course reusing old test plans and changing things that so it's relevant for the new test. But these test plans are actually essential for the success of our mission here. If we do not know how to create and use a test plan, we have to start from scratch again each and every time. So, but I was talking about earlier on the big rocket we are building. That's the Speaker rocket. It is 20 times more powerful than the earlier rockets, the Nexus class. We launched in 2016 and 2018, and we decided to step up to not to an intermediate size, but the full size that is human rated.
Step number 54, evacuate test area. We are ready for ignition.
We are very close to ignition now. We expect a number of tests today. You can see in the background people are moving away from the test area because we are evacuating the test area.
Crowd Alpha, this is Crowd 2. That is good. Crowd 3, this is Crowd Alpha, check in. We all put out. Crowd 4, this is Crowd Alpha, check in.
And right now people are
Crowd 5,
coming together here up here at the test stand, and I have to get some help because the test stand camera is still frozen. And Can anyone help with that? Could you? What were you doing with the test? Remember that. This is Daniel. What did you do with this to make it work again?
I closed it and opened it, unfortunately.
Is that it? Okay.
Yeah, but then I can also try this one. 1 second.
The properties, yeah?
Deactivate.
Yeah, okay. And then activate it again?
Good.
Yeah, nice. Oh, you are
Luckily
gold.
enough.
You are gold. Yeah. Because I was just talking about people coming together up here, and because we are ready for the test, and we are keeping a distance. It will probably not explode, but you never know what happens in rocketry.
Alright, we're ready to start. So, moving on, section B, pressurization and firing checklist. Step number 55, announce pressurization and subsequent firing. That's exactly what we're doing now. Step number 56, data, engage glow plugs, 60 seconds warm-up time.
Yeah, 60 seconds. We. Yeah, you will.
Both works, engaged.
Uh-oh.
Understood. Now we're doing the final go, no-go sequence for pressurization and subsequent firing. Step number 57, crowd alpha, go, no-go for ignition. Crowd 3. Can you check what those people in front of you are doing?
Nobody, yes, we will talk with him.
Are they inside or outside of the range, and are we good to go or not?
Crowd 3, inside or outside?
He's outside.
Okay.
Crowd alpha, clear. Understood. Step number 56, booster to go, no-go.
Yes, we talk with him. He is here to squat. All good. Crowd 3 out.
Alright, let's try again. Step number 58, booster, go, no-go for ignition.
It's a go no go sequence right now.
Water, go, no-go for ignition.
Everybody has to.
Understood. Photo, go, no-go for ignition.
They have to
Go.
say if anything is ready for that from their point of view.
Attention all hands, this is flight. We have a green board. Pressurization and firing is imminent. We are good to go. Stand by.
And then we close down the area completely, and no
Just
one.
remember, everyone, test area remains restricted area until booster declares the range safe. Step number 64 is go. Pressurized tanks and firemen ready.
There will be some delay between some of the cameras, but let's see. 26 seconds. We're just listening in.
Minus 10 seconds. Minus 5.
Whoa! Yes! Yeah, okay. Okay. Last time it was called the bourbonizer or whatever. And of course the area is restricted until the pad leader has cleared the flight. In this case, he's just wearing a T-shirt or a vest saying Pat, but he's
Attention all hands to
the
the
flight.
slide. This seems like an interesting, positive ignition.
Yeah.
It looks pretty good. Data is now reassessing any changes in the tank pressures, and we will be preparing for an imminent second try. Stand by for further data. Mission out.
And we noticed this actually it doesn't seem that we have any fire down there, so we're just trying once more and letting the glow blocks cool down and then heat them up. We have a 60 seconds heat up time. It's a bit long, but we have made some tests the other day, and it was inconclusive how long it had to be turned on before it could ignite the alcohol. Sometimes it was just a few seconds, and sometimes it was 40 seconds. So now they have this 60 seconds heat up period just to be on the safe side. So, but it looks way more promising than the last test we had. In this case, we also had these burps it makes when you have gaseous oxygen and vapor from the alcohol inside the chamber, and it suddenly ignites because of the hot glow plugs. It explodes and inside the rocket, and it blows out everything that is in the combustion chamber, and then because everything has been blown out, there's nothing that can actually burn in there until a bit of oxygen is coming in again, and then it can reignite, and we see this pulsing effect last time, and strangely enough also this time. So I have to ask later on if the glow plugs still were running or they had shut them down. That could be interesting to know, or if it was a self-ignition. We don't like self-ignitions in this business. But let's see. It could be interesting to see the data. Yeah, we are live.
And camera set. Okay,
Yeah.
attention all hands, this is flight. The parameters now being readjusted. The ignition and the temperature seemed okay, but the chamber pressure was very low. So essentially we are increasing both of the feed pressures, maintaining the same OF ratio, expecting to get the same temperature but much more gas flow. So it looks promising.
Really?
We'll be ready soon.
Any news about the temperature in the chamber?
Inconclusive reading.
Inconclusive reading, yes. It happens sometimes. But what we are trying here is to...
Attention all hands, this is flight. All parameter changes have been implemented. We will start again with engaging the glow plugs, and about a minute later we will pressurize and fire again. So data, please enable glow plugs, 60-second warm-up time.
Yeah. Glow plugs again. What we're trying is to get a combustion where it is choked inside. It's so the pressure is high inside the combustion chamber and stays high in there, and that's why we have this. You see the nozzle that is small, so the combustion gases cannot escape fast enough. So the pressure rises inside the chamber, and we want that a choked combustion inside there, so we can keep on having a self-sustained fire inside the combustion chamber. 10 seconds. Ooh, listen up. Trying again.
T-5.
That's interesting. Well, everything in this business is interesting when you're trying it for the first time. And it is a new way of igniting a rocket engine, so it is a bit interesting, this. What happened there?
Water, flight.
Yeah, they are a bit concerned if there should come a fire down there. They are you can actually see it on the camera at the top right. They are flowing a lot of water, opening valves to flush out the floor in the container. One of the things we can do with this system is actually what you just saw. We can repressurize and fire again in a few seconds after, within a minute or so. No, it has to heat up for a minute, but a few minutes. Still keeping an eye on the area because we don't want people to get hurt or something, or just being scared. All the neighbors in the area have received a mail that told them what happened, and the local police has got a mail describing exactly what will happen today. So if people calls and says they are hearing weird noises here, and the police should look at it, the police just say, well, we know they are playing with the rockets out there, so no problem. It's a bit difficult to see on the camera, but right now they're discussing the data, and he's discussing what the next approach might be. Can they adjust on the pressures and so on, and see what's happened? This last test looked a much more different than the first one. So, well, everything here is about data. We need the data, and we need as much data as possible in the shortest possible time. Now, let's see. Could flight say anything about this?
Sorry, this will be a joint announcement.
Yeah.
Okay, attention all hands, this is flight. The second ignition attempt had a lot more propellant flow, and it looked like we actually had a delayed ignition. So we only got the last part of those 10 seconds of the burn, and it seemed like our glow plugs might have been slightly flooded, delaying the ignition. So essentially we're going to go back to the first attempt we did with less propellant flow, but then we're going to try and let it run for up to 45 seconds and see what we can get. We did get a temperature reading of about 650 degrees on the temperature sensor in the second run, but we will try to collect some more, let's say, steady state data on the initial lower power setting. So that's the plan. Mission out.
Thanks. Yeah, you heard it from the horse himself. So we are simply going back and trying again.
We'll be venting some tanks to get down in tank pressures.
Oh. Everything is done remote, and it's very important for the safety. We can flush the floor with water. We can pressurize, and we can release pressure and so on. Everything is controlled remote, so we don't have to go close to the test site. And an interesting thing, when we don't have to go close to the test site to do something, we don't need to take off the full pressure of the tanks. That means the next repressurization will go much faster and so on. So the more remote control we have, the faster we can do this test, the faster we can collect the data, and the faster we are going in our approach against the Speaker rocket with the five big rocket motors we are building on right now. And each of these motors are 5 times more powerful than the old BPM-5 rocket engines from the Nexus 1 and Nexus 2. So,
Okay, all hands, we're ready for the next attempt. This will be on the lower power setting, but potentially up to 45 seconds. So, data, please engage glow plugs after witness step 56, confirm. 60-second warm-up time. Data, your go for step 64, pressurization and firing at your discretion. Over.
Come in, take that. Countdown has started at 30 seconds. Minus 20.
the third test, yeah, it's really going fast.
Minus 10.
Okay, let's see what happens.
Minus 5, 4, 3, 2, 1.
Come on. That sounds right.
Okay, attention all hands, this was an interesting and rather successful test. We ran 45 seconds, it shut down automatically. We will have to look at the data because it looked like the combustion became increasingly stable across the 45 seconds. The engine pipe, even though it's frankly uncooled on the outside, it did not seem on cameras to reach an excessively high temperature. We'll get right back to you as soon as we've taken the first look at the data. But very, very nice burn. Thank you. Mission out.
Oh, I think it's the first time in history we've had a 55 seconds burn of a rocket engine, but of course it's another kind of, it's not a real rocket engine. It's not made for filling up thrust, but only for making a lot of hot exhaust gases. And it does not burn as hot as the other rockets. Rocket engines has typically a temperature at around 2800 centigrades, and this we are running around maybe 600 or 700 centigrades. So it can run a lot longer without cooling, and we don't have cooling on this one. It's made of stainless steel. We have not used stainless steel earlier for rocket engines, but in this case we use stainless steel, so it can withstand the temperatures, and this is one of the reasons why we were able to survive a 45 seconds burn. But we'll look into the data and see what actually happened. It was a bit slow start, but then it began sounding actually like a steam locomotive, something like that. Interesting. There was some slowly pulsating sounds. I'm really interested in looking at these data now. They are, you can see in the on the bottom left, they are collecting around the screen with the data, and they are. I'm a bit envious right now, but they are looking into the data, and then they have to take a decision about what's the next test. Yeah, as I see in the chat, it was very hot out. I think I maybe saw a little metal spark or something like that. But let's see what happens. It would be interesting to see, look closer to into the engine itself and see what happened to the engine, the hardware itself.
Okay, attention all hands to this flight. We have decided to actually redo this one, although we might push it for up to 80 seconds this time around. It looks like it takes this burner quite a long time to get to a steady state combustion, and we actually seem to be approaching thermal equilibrium at the end of the last burn. So yes, it seems like it's excessively long in time to get to a steady state, but some of those steady state numbers are actually the very most important ones for us to figure out whether or not we got our math right on the OF flows, the mass, etc., etc. We also got a decent chamber pressure by the end of this burn. So we'll be going for up to 80 seconds if we have enough fuel and pressurization gas for this. After this, we will have a scheduled shutdown and inspection.
80 seconds of burn. It might be the end of the rocket engine, but let's see what happens. How much ethanol does it burn per second? It's measured in grams.
Data step number 56, engage fuel plug igniter, 60-second warm-up time. You are authorized for step 64, pressurization and firing at your discretion. Finish now.
Enabling fuel plugs.
There's a question about the testing site. Yes, it is open for the public. Today we have closed a part of the area off, but we have a public area for spectators, because rocket science is a spectator's sport. I don't think other teams and students can test in this area, except if they get the permission from the company that owns the area, like we have done. We have, well, 20 seconds.
15 seconds.
Yeah. We just have to listen and see what happens.
T-minus 5, 4, 3, 2, 1.
And now it's glowing. It's glowing red. Yeah, the purple color. We are famous for our purple colors, but it's because there's a bad infrared filter in that camera that makes the camera actually see the infrared radiation, and that makes a purple glow. So it's actually not purple. If you look at it with your own eyes, it would be orange in color, but the camera looks at it as infrared radiation and thinks it's purple.
Understood.
Yeah, it's a SpaceX level cadence. Yeah, seriously, it is not a rocket engine in the classical class. It is a heat hot gas generator simply. So, and it's burning at a way lower pressure and way lower temperature than any other rocket engines.
I have an update.
Yes, nice.
Okay, attention all hands, this is flight, so an update on the last burn here. The last burn was intentionally and prematurely shut down. It looks like we might have liquefied one of the O-ring seals on the injector side, so we had a slight bit of alcohol burning near the injector, so we just decided to shut down from that. Besides that, it seems like we now have a decent and steady combustion with reasonable pressures. This little pipe is actually quite noisy when you're out here on the field. So essentially, this is now a shutdown. We vented both tanks. We'll cool down and we'll do an inspection, and then we'll see if we want to change nozzles and go for another test firing session. So for now, we're doing pretty good, but we'll be going a little bit into a break for now to assess the situation, and we'll get back to you.
Oh, yeah. There are a couple of good questions here on the chat. I had to write them down here. Yeah, we like the purple color too, Louis.
Data flight. Full flight. Can you confirm that glow plug igniters are disengaged? They are disengaged. Data flight. Full flight. High pressure tank reading, please. High pressure tank reads 96 bar. Understood, that's considered safe. Mission out.
Yeah. Well, Simon 9580 asks, what is the test objective? The idea is we are trying to find a way to have a stable combustion in this kind of engine to produce a sufficient amount of hot exhaust gases to be able to boil liquid oxygen and superheat it to use that for pressurization of our tanks in the speaker rocket. But right now we just have to show that we can establish a stable combustion in this rocket type, and if not, we have to go back to the drawing book and maybe make another kind of ignition or geometry of the engine or whatever. We don't know quite right now, but The most important thing is to get as much data as possible from the testing here. Yeah.
Alright, data shut down. Bottom water, please. Bottom water is off.
Yeah.
Alright. Attention all hands. We hereby declare the test range safe. Video, please shut down your cameras.
And now they are just, running down, shutting off cameras. With these many firings in a short time, there is one problem if we are running the high-speed cameras, because if we are testing so many times in a row without going down to visit the test stand down there, then we can risk that they run out of space.
Okay, attention all hands. This is flight. Range is safe. Range is safe. Everyone can come to the test container, including audience if they want to look.
Yeah, it should be safe now. I think I'll take a short break now, just 2 minutes, and then I'll be back, maybe with someone we can ask what
Sorry, Bianca, did you have something on the radio?
what happened. Bianca? Bianca took the radio, so you can't follow it. No, that's it. Couple of minutes. I'll be back.
How does it go streaming?
It goes pretty well.
Meget stridt. Ja, vi kan no. Nogle tanker med styr, og jeg har lidt problemer med visning af data. Så jeg ved ikke helt om det er rigtigt. Ja, okay. Yeah, we got, is it streaming still? Okay. Oh no, let me try. Are you listening to it? Just to see if you can hear it better.
Would you like some chocolate bars?
I'm fine.
Oh,
Vi kører stadigvæk med livestream her, eller hvad?
List of audio media source.
Nogen i chatten, der sidder spændende? Nej, ikke noget. Det er en fra Svalbard. Martin fra Svalbard. Kender jeg dig, Martin fra Svalbard?
so Martin Bingo.
Okay, better now. Test. Can you hear it? No.
Lose the mic.
No.
Try again, try again.
Test. Can you hear it?
There's a delay. There's a 10 seconds.
I think it's okay.
Hmm?
I think it's okay.
Okay, but then. Okay. But then I think it's simply that you have it very far from the mouth.
But it was working quite well, just lying there, or sitting around my neck. I usually wear it like this, because if you do this, I have a problem, because I'm left-eared. Everything that goes into my left ear overwrites everything that happens in my brain. If it's so I can't. If I hear anything in the left brain, I react to it. Yeah, but it doesn't. And if it's in the right ear, it's okay. I can speak and do everything if I hear the sound in the right ear. Doesn't matter. But if it's in the left ear, it overrides everything.
And you got a headset that's specifically only for the left ear.
Yeah, unfortunately, because I couldn't get it for the right ear.
At least if you keep the microphone, I guess.
The microphone is really good.
Just keep it, I think, around your neck. And then just keep the microphone up.
Yeah, and I just put it down here around my
Kind of, and then maybe.
You can move it up and down. And sometimes I forget it and it sits over here. But it works fine lying on the table.
Yes, I can hear the testing. Nice. Thanks
Thank
for
you,
the
Simon.
confirmation, Simon.
Thank you very much. And Peter Skødt is asking how much ethanol does this device burn per second. I just I answered it. It's measured in grams or milliliters, but I was just asking Scott if he could remember, and he couldn't. And he's sitting with all the data, so we are using common oil burners, actually common injectors from oil burners. For this test, we have usually made a lot of different injectors with a lot of holes, like impinging showerhead injectors, where you have hundreds of holes where the streams of liquid oxygen and alcohol is hitting each other and making this spray pattern of the mist of frozen alcohol. But in this case, we use common oil burner nozzles that sprays out, and it's a really good alternative when you're using so low a flow rate of liquid oxygen and alcohol. We have some problems with igniting it, and this is one of the things we're looking into. But we are actually talking about making a an augmented glow plug igniter, where we have a glow plug that ignites a mixture of alcohol and oxygen in a small chamber at a low temperature, making a long flame coming out into the chamber, where it will ignite a mixture that makes a much hotter combustion. So we're working on different methods, but
Yes, go ahead, flight.
Just one word of caution: work around the injector and that O-ring that overheated. That is blue glove work. Repeat, blue glove work for mechanical work around the injector.
Blue glove work is when you need to keep the things very, very clean. We have procedures for cleaning everything that comes into contact with liquid oxygen. It has to be very thoroughly cleaned up. It's a long and tedious procedure. So when you have something you afterwards want to touch, you need to be very, very clean and use, among other things, gloves to make sure that you don't put some grease into the system where you have liquid or gaseous oxygen, because that can be give us some problems with the ignition inside the oxygen tubings. We don't like that. So. Yeah. Just yesterday I was preparing a lot of gaskets for our system, where we are using copper gaskets many places, and these copper gaskets has to be annealed, where we are glowing it with a hot flame and then dropping it into ethanol to take away the oxidized residue on top of the O-rings, the copper rings. By annealing the copper, glowing it and throwing it into alcohol, the copper becomes very soft, and we are able to squeeze it when we are tightening, like the oil burner nozzles, and while squeezing it, the copper flows out in all the tiny grooves and so on, and tightens it very, very thoroughly. Afterwards, when we are taking the nozzle out, we have to use a new annealed gasket for this, for remounting it, or we have to re-anneal the copper gasket we are using, because when you are squeezing copper, it becomes deformation hardened. It becomes harder if you press it or squeeze it or hit on it. And to make it possible to squeeze it once more time, so it's making it soft, you have to anneal it by glowing it in a gas flame and putting it into ethanol. We do that with all our copper gaskets, and it's a bit tedious. So yesterday I made a lot because it is easier to swap old gaskets out with the new ones, but the new ones has to be a neo. So I made a lot of them yesterday, and right now I hope they are doing the right thing and changing the gaskets down there. Let's see who's working down there. I almost can't see it. I think it's Valdemar, and who's the other one? It might be Mineke. Oh, let's see. And they are wearing blue gloves. Oh, it's difficult to see. Maybe it's Leon or no, I can't see. We need a be back soon screen here, but we haven't fixed that yet. But lips, I'll just move a bit of this. We have different cameras. Some of them are quite old, so they have different formats and so on. So I'll try to adjust this. Maybe I can. It'll never be good. One of the things we are missing a lot is cameras for our live streaming and for our documentation and so on. We have had so many cameras and we have lost a lot of them, and you can almost think by yourself that exposing these tiny action cameras to the flames and the dust and so on a test stand during test campaign will deteriorate the cameras, and we have a lot of our cameras is actually simply in too bad shape, and we need some more. So if anyone knows someone who maybe can offer old action cameras, older version of GoPro cameras, let us know, because we really you can never go down for cameras in a business that is so spectator oriented. So we need cameras, and another thing we have gone down about is actually our we have really nice radios, high quality marine radios, but a lot of them has deteriorated battery packs, and the battery on one of these marine radios costs £300 if you want to get a new one, and we simply cannot afford that. So we have got, many years ago we had a lot of radios sponsored, but when the batteries are dead, we have no money to buy new batteries because they cost £300 each. And so we are looking into something where we can, get new batteries or find a good alternative to these radios with cheaper batteries. That's one of the things we are in. We need for the testing here. But also streaming cameras and anything. It's not. It doesn't have to be very high quality, and it can be roughly used and so on. But we need a lot of cameras for the documentation, at least. Do-it-yourself battery packs. We've actually looked into it. We desiccated one of the batteries, and it is we cannot do that. It is very high quality, but we are talking about maybe 3D printing an adapter so you can use another kind of batteries on these marine radios. Then okay, it will not anymore be ATEX qualified. These radios are meant for use on oil platforms, isn't it? And so it's they are safe to use in a gaseous environment with explosive gases and so on. But we could, of course, if we made this kind of adapter, that would not be possible anymore. But we don't need that. We don't need that quality of the radios. So that might be a possibility to make a 3D printed adapter, and then you can put a DeWalt battery or something on it, and it would look weird, but well,
We have the temperature probe out of
if it works.
engine, the chamber, and I was just wondering if you could see if the data is something that makes sense at the moment. The sensor is definitely alive.
Okay.
I'm just going to put my fingers on it and see if it goes up in temperature. It may be, but I have some fluctuations on all the temperature readings, so it's difficult to tell. Is there a way where we could tell or not? If you have a little gas flame so you can heat it up to a couple of 100 degrees.
Yeah, they are asking for a lighter.
At the moment.
Just a second. I have a lighter if they want one. Just a second. Where is it? Here. Take care. It's a jet lighter.
We could also put it on the locks pipes.
So now on the top left view, you can see Bo walking down to the test stand with one of my lighters, so they can test the temperature sensor and see if it is for real alive as they expect. That's one of the crucial tools we have in our toolbox. That is a common lighter. Yes, for testing, of course.
Data booster. Okay.
back in a couple of minutes. meste af den, så
Ja, den kommer op over 500 grader.
ja, det er hallo, mand. Yes, and the lighter has shown its purpose, and this lighter has demonstrated that the temperature sensor in the rocket engine actually works. So this is rocket grade tool for the future. Yeah. The rave chat. Can you hear the rave music in the background? Because there's actually a kind of concert going on over there with some rave music. They're running sometimes, well, 24 hours and night and day with this music. And we're just helping them with a bit of percussion sounds. I would like to know what the status is down at this test stand, so I think I will just go down there and talk with them. Unfortunately, I cannot take you with me down there, but I will come back with the briefing as soon as I know something. So, see you in a while.
Attention all hands, this is flight. Booster reports that the inspection and reassembly of the engines should be done in approximately 20 minutes. As soon as they're done with the engine and report that one ready, we're going to restart with loading additional liquid oxygen and nitrogen, and then we'll be starting on the next test session as soon as we can get away with it. Mission out.
Now it's
Is
again.
anybody in help?
You see?
Oh,
Like this it
okay.
works.
That's nice.
Lukas, baby. Sami, kunne du bringe nogle servietter eller paptallerkener med, når du kommer tilbage? Servietter kommer out.
There's a bit of chatting in Danish on the radio because Luca is preparing some food for us, hot dogs and so on, so we can have some a bit of snacks. It would be nice, and it's happening in the HAB, the horizontal assembly building, which is approximately 500 meters from here. No, 450 meters, and so it's a nice thing to have these marine radios, so we can speak to each other about when the food is ready and so on. I was down at the test stand and looked what was happening. It's actually for some reason we're not quite sure, but the glow plugs were not tightened correctly, or they had loosened themselves. So I was talking about these annealed copper gaskets. It didn't work because the whole adapter for the glow plug was had loosened itself, so it wasn't tight. There came some fire out there, and there was some another place down where I think it's where the oxygen comes in, where it hasn't been tightened correctly. So so there was a bit of fire down there, and Oliver asked if it matters whether these gaskets are annealed now that the engine has been so hot, so maybe they are self-annealing now. A new trick, self-annealing copper gaskets in our rocket engines. Yes, that's a completely new thing in Copenhagen Suborbitals. Yeah, Michael Dipper is talking about that there is actually some rave party down there. The Reffen, this Berghauser is saying that it must be a Reffen, where they have a vinyl market today. I didn't know that, but it's not there that we have a lot of sound coming from, because that's way further 800 meters or 900 meters, and it's behind some buildings. They had a big concert yesterday. We could hear, but right now there's no sound from them. But we have a lot of sound from an old hangar over here where they have these raid parties and so on. But they are assembling the whole gadget down there, the tiny rocket engine again. If there's anyone new to this live chat, no, not much. But yeah, we are testing this liquid nitrogen evaporator engine, kind of a hair dryer on steroids, 300 times the normal hair dryer. It's producing a lot of hot gases that we will use for boiling, evaporating, and superheating nitrogen later on for our test of the BPM 25 engine and for the Speedcat rocket itself, with 5 of these BPM 25 engines inside. It is a way, we're trying to find a way to pressurize the system without using too much money, because we are not in the capability of making our own pumps or turbo pumps for the system. It's really difficult. We have a lot of new machinery in the workshop, or not. We have some new machinery we have built from scratch for ourselves. Right now we have one of the things is a very big plasma cutter we have built. It's I think 4.5 times 3 meters for cutting big steel plates out, and we have a Maho mill. It's actually a mill from back from the 80s. We bought very cheap, and then we ripped out all the electronics and rebuilt it ourselves, and designed a safety enclosure and rebuilt a round turntable with so it's computer controlled, and it's kind of 5-6 axis ish. Some of it is manually, but some of it is most of it is electronically and controlled by computer, and that has been a very great thing to have in our workshop. And furthermore, this mill has been used to refurbish a old large lathe. We've got a manual lathe we got almost for free. Sometimes I say it's for free. It was for free, but it is not. We actually paid as much as 10 strawberry pies for this big lathe, and we found out that it had a lot of slop in it, and a lot of clay, and we had to take it apart, and we couldn't repair it, so we simply chose the best option, that was to rebuild it from scratch, making our own parts for it on the mill, out of scrap metal and so on, and rebuild a lot of electronics for it. So now we have a big lathe that is CNC controlled and semi-electronic, semi-manual, electromechanical. You can change the way you use it in a lot of different ways, and it is really precise and a good thing to have together with the mill. Furthermore, another thing we have done is lately this very big plasma cutter we have. We found out that it was so precise that we got an option for making Kevlar parachutes, and Mads Stenfat, that is our parachute manufacturer and designer, he opted for using a laser he had bought I think 6 years ago or something. We just never have used it, and then Scott designed a system where we could use this laser, and began cutting out the fabric for the parachute, and it actually worked. It was a bit slow, but it worked, and the next thing was that we bought a 20-watt laser. That is 20-watt output laser, and it's really a workhorse for cutting out complex shapes in Kevlar fabric. So it's interesting, and it could be used for a lot of other things, and we're looking into that. Maybe for the seat and so on. It can cut EVA foam and so on. So it's quite interesting, an interesting upgrade. So we have upgraded a lot of things, mainly because when designing the speaker, we were talking about a 100 kilonewton engine, and we were trying to design that. We found out that it was simply impossible with the things we have, the machinery and so on. We couldn't do it quite as a 100 kilonewton engine, and then we changed the attitude and designed a system with at least four engines of a smaller kind, the BPM 25, and we found out that it was actually a lot better a much better solution, because now we are actually we can gimbal the engines and use that gimbaling to steer the speaker rocket, and then we place a fifth engine in the center, because we are notoriously bad at weight budget. So the rocket often ends up weighing more than expected. So with an extra engine in the center, first of all, we are able to help with this weight budget problem, and we can just shut it down during the flight if we don't need it anymore. Furthermore, it makes the rocket engine compartment look like the Saturn V rocket, and that's also a good thing. got a good Danish hot dog with remoulade and pickles and sorry, I'll be away a bit while I'm eating it. YouTube. Yeah, we could be cut off due to copyright music, but as Peter Scott said earlier on, we hear mostly the bass thump, and that's correct. As actually when we are working out here in the summer weekends, we have this bass drum hour after hour, all day long, all night long, and so on. to put up this live stream. Jens Bøster there on the chat was one of our members that was made the latest stream, and we are trying to use this system called OBS project or OBS Studio, and we had a lot of problems making the cameras work, and we tried to open them and connect to them, and suddenly the cameras froze and everything froze, and we had to reboot the computer, and we tried again, and then suddenly we realized that each time we had made a connection to a camera, we ended up with a new connection to the same camera, and we had 20 cameras on top of each other, and then everything went haywire. The moment we moved the windows, we saw what the error was, so we had some problems. Yeah. Jens, you say well done to Jørgen and Bianca, but basically I was standing more in the background when it happened, because one of our new guys, Daniel, was cooperating with Bianca to make this function. And it helps. I'm up in the age. Maybe it's difficult to see, but I am older. And the young people are actually, I must admit, way faster to find the correct, interesting information on the screen and choose the correct information and so on, and switching from one computer to another, from one site to another, using the mobile phone and so on, fast and trickle around much faster than I. We found out to this chat there was one thing we needed. Bianca came and talked to me. We need a I'll be back screen. When I go for a few minutes, we need something where we can show a video or whatever, something, a pause screen, maybe fish swimming around, or rocket engines exploding, whatever, just for the entertaining in the period where I am away. But we have to create that first, so we can switch to that scene in this system. So. Right now I'm sure what is happening. They are standing talking about the data, and I don't think they are actually focused on the test right now, but focusing on other interesting aspects of rockets and data from... Yeah, that was Michael waving. So. Jacob is sitting writing notes, probably planning for the next test. Seems there's a lot of discussion up there. Unfortunately, we can't hear what happens in mission control, so we'll just have to wait and see. seems
We're gonna try and switch
we
around
have
a little
a
bit.
briefing
We'll be
now.
running 2 load sensors at the end this time. Both of them will be up to 80 seconds long, so probably the test is on. We will have to do blocks, so we're gonna run 2 load sensors. In order to get some key wording and looking a little bit on what we're doing around the test container, there is now a switch out toggle. So we can't, I can really try to rotate the load, but I can't rotate everybody to 2 roles to just 1 station. It has to be 2 stations. Currently, Crowd Alpha responsibility is switch away from silent to speed up. There we go. We've done it in 6. Okay, that means on the crowd
Oh, something happened there. I'll just tell you here because right now it's a bit difficult here to. Oh, just a second. I have something here. Properties. No, well, the thing is we are right now starting a new test session, and to make that possible and make sure that people are learning all the different procedures for another test, we are trying to rotate the roles people are playing. So a new person for flight, a new person for the booster, and moving some of the people who are taking care of crowd control, as we call it. It's our nice service personnel. They are moving around, so they maybe have the possibility to do some more technical stuff and so on. It's very important that as many people as possible in Copenhagen Suborbitals knows as many as possible different tasks and have tried it. So it makes it a lot easier to talk about and to decide what to do in the future. New firefighter, new booster, new flight, and so on, and of course the same account for the crowd control. It's a bit annoying to be crowd control a whole day because they are actually just standing out in the area and trying to keep people away, and you're not you don't feel like you're an active part of it, and that's why it's a good idea to another reason why it's a good idea to rotate. I don't have to rotate. I've tried all of it almost. So and I'll take care of this live stream. And no one else likes live streaming. So that's another reason. Maybe I'm kind of they let me alone. Daniel, the camera froze again. I was just turning it and then it froze.
Yeah, I don't have the cable.
masking tape, or what is it? 3?
Yeah.
That's another reason why we need new cameras.
There it
They have
is.
deteriorated everything. Yeah, okay, man, that looks nice.
But as you can see, there is some art.
Can you try to turn it a bit now over to the mission control, because now everybody has gone just to the mission control. Yes, it seems to work. Yes,
Okay,
it's
yeah.
still working. Yeah.
Like
Nice.
this?
Yes, perfect.
Not frozen, right?
Yeah, it works. It's not frozen. Yep. He's moving. It's not a glitch. Oh yeah. Now we are, when we're starting up again here, after we have made service on the rocket engine, we have to step back and start the test sequence here. Earlier on, and this is, I think we have fuel and locks ready, so we should. They'll have to check if they have enough alcohol and oxygen in the tanks, because pressurization is done remotely. But we can, of course, not fill the tanks remotely. So let's see. I don't exactly know where we are in the test sequence.
No problem for us. Understood, thanks. Current pressure in the diving tanks is 94 bars.
Oh, yes, let's see. The number of different injectors, it was planned to make
This is Lux. Let us know when this is stabilized.
it was planned to switch nozzles, I think 2 times, and there's 3 different nozzle sets, but I don't know how far they have come with that. Yeah, we've solved the frozen camera. It was basically because the USB connection to the camera has been repaired 1, 2, 3 or 4 places to make it just work sometimes. So that's how it is. And then we had this.
Unfortunately, his data, the pressure has stabilized around 132 bars. Understood. Thank you.
We had a there was a USB disconnect. It was actually me who was disconnecting the microphone, so maybe I could get some sound from the rebriefing and the task switch operation, where they were standing in a circle and doing that. But the telephone, the microphone wire was not long enough. Yes, the stainless steel. When you're screwing stainless steel threadings together, you can risk that they are. I don't know what is this named in English, but it's like they are almost cold welding together, and you can't get them free again. And then usually you lubricate with some kind of special grease.
This is Logs. We're about to start the nitrogen compressor.
Oh.
Roger that.
But in an oxygen-rich environment, you cannot use grease or anything like that for threading. But there are types of lubricant that are LOX compatible, so you can easily find it. So yeah, it seems they are. It sounds like they are not high enough pressure in the diving tank. We have a special diver tank with high pressure nitrogen we use for pressurization. It's necessary because we simply cannot get the nitrogen out of the flasks fast enough, and so we have a diver compressor that pumps up these diving tanks with the high pressure nitrogen, and then we use that for pressurization, and right now they were talking about starting this annoying diving compressor because it's a lot of noise and it takes a long time, unfortunately. But they were talking about that, and yeah, let's see how it goes. So.
Hvor er du lyst til, at vi tester inde i deres det, vi har klar?
This is Vox. We're targeting 200 bar in the high pressure nitrogen. Can we please have an advance warning at 190 bar? Yes, Data, yeah, no problem. We are currently at 142. Understood, thanks.
Så kører over for sådan der.
so please crowd people to your stations. We're not in range lockdown mode yet, but we will be soon. Stand by. All right, data flight. Flight this is data. We would like to add an additional point before step number 35. We would actually like to have both globe clocks re-engaged to verify operation after we disable the engine or disassemble the engine. So please enable both globe clocks. Over. Roger, enabling both globe clocks. Globe clocks enabled. Okay, we're confirming both globe clocks operational and hot. Please disengage globe clocks. Disengaging globe clocks. Globe clocks is disengaged. Understood. Then we will do quite a bit of skipping because we will not be refueling this system. We have no high-speed cameras, so step number 42 is also disregarded. So Crowd Alpha, step number 43, please start your range perimeter check and secure the test range. Over. Crowd is securing the perimeter at the moment. Understood. Feel free to chime in when you're ready, when we're in a fully safe state. Over. Okay, step number 44. We now currently have the range clear, or the test stand area clear of non-essential personnel. There is a lot of personnel down here, but it's a learning experience. So step number 44 complete. This is Lox. Lox, this is Taylor. Holding on nitrogen pressure. Recorded reading 174 bars and slowly rising. Thank you.
When you're trying to zoom something, you have to do it on the right camera. Yeah. Snore. Seems the protective tent around the mission control is trying to fly away. So they're trying to save it, secure it. The best place to watch on location, well, that's where we are. On Refsaløen, the old Burmaster and Wayne shipyard, where we're just sitting here. Copenhagen Suborbitals were the last to build a ship on Burmaster Wayne's location here. On the old shipyard we built the catamaran Sputnik many years ago in 2010, and it was built out here, and it was the last ship ever built on the shipyard. unfortunately we had to scrap it a couple of years ago. It hurt a lot, but we had to scrap it because when we were just about putting it into, and it has been standing on land for a long time, and when we were trying to put it into water, we inspected it and found out that if we put it in water, it might end in a rescue operation that would be even more expensive than building a new platform. So the choice was easy, but it still hurt a lot.
Okay, attention all hands, we are ready now to commence the LOX loading down here at the test range. So we are going through the go-no-go sections for LOX loading. Data, step 45, are you
yes,
LOX loading?
Trash Rocket, you are at Lynetten, that is quite close. So if you go out to the area, we're actually just in front of the big BRV building, the S2 building. You can see behind me. It's a big one with the wolf on top. And
information, you're currently at 191 bars. All non-essential personnel is out of the test stand. We will proceed with
behind me,
shortly.
you see the test stand. And behind that, there is a public area where you can come and see and or more listen to the test. So that's you're very welcome. And if when you are there, you can buy some of our nice new tags here. Copenhagen Suborbitals, remove before flight.
Okay, attention all hands, this is flight. We are now have completed step number 48. We are good to start loading liquid oxygen. Step number 49, the target loading target for liquid oxygen is now 40 liters, 40 liters. Can you confirm you have that data? This is data, we can confirm 40 liters. Understood, that concludes step number 49. Data, can you confirm step 50, LOX vent valve is open, over?
Oh yeah.
This is data, LOX vent valve open. Excellent. Then we're loading LOX, liquid oxygen, step number 51. LOX, please commence loading to 40 liters.
It's a standard tedious procedure. You have to release the pressure from the liquid oxygen tank, then you have to let it stay open, then you force liquid oxygen into the tank, and then fill the tank up until you feel you have enough. We're going for 40 liters or 40 kilo. It should be kilograms, but that's our target, and when we have
200 bars at the high pressure system.
Yeah.
Noted, we're shutting down.
Yeah, shutting down the diving compressor, not the test. Okay. But we are loading LOX, and when we have reached the target, we can stop loading and then close the vent valve, and then
to slowly open the needle valve on the LOX door. Could you inform me of the pressure? Currently we're reading 0.27 bars. I repeat, that was 0.27 bars. Understood, thank you.
our old sandbags, actually I don't know where they are. Maybe they were rotten. So Trash Rocket, you gotta hurry with you if you wanna follow the next test. We are just filling up the liquid oxygen tank with new locks.
Locks, this is data. On the pressure. You're currently at 1.0 bar. 1.0 bar. Okay, I'm going to open it a little bit more. Roger, monitoring the pressure. Please inform me of what the rise is to. We are reading 1.2 bar. Okay, I understood. Open setting on.
Crowd live streaming here. Hey Bianca, where crowd control? The guests down there. We have guests.
Because I was looking at the ones that are sitting up there, like, do we want them there?
Okay, there, yeah, I don't know why, but maybe it's a good idea to put them there and this. There's something that's not right.
But I mean, the guests right now, it's not like they have somebody.
They should be over in this area over there so they can see the flames coming out, if they're coming flames out.
There's something to the power.
Who's at the truck?
Mike Cooper, I think it's Cooper from the side. So,
There was a guy here. Yep.
Yep. So
We're reading 1.7 bars.
Yeah.
Of the wolf, right? He must know what it is.
Yeah. There's an area just about the wolf at the red line, but so they can see what's coming out.
5.9 liters. 26 liters out.
Have they emptied the LOX tank?
Huh?
Have they emptied the LOX tank?
I mean, I can
That
see
looks
the-
like an empty LOX tank they are trying to fill up.
Yeah, I don't know.
Because then it's gotten hotter. Yeah. So it's boiling.
This is locked. How is the reading pressure looking? We're currently seeing 2.2 bars and rising. You might want to decrease a bit. Decreasing now, understood. We're also reading 32 liters of flux. Thank you.
Okay, it's empty. The LOX tank has. I thought it was topping up the LOX, but it seems it's run empty. That's a problem we have when testing and it takes too long time and a too hot day. It's quite hot right now, and the liquid oxygen is boiling off. We're not using much for the test itself, but we're using a lot for cooling down the liquid oxygen to keep it liquid. Yeah.
There was a saying that you have to continuously vent off.
Yeah, they have to keep it vent. They have to vent constantly to keep it boiling.
How are we on pressure and volume for LOX loading? We are currently reading 2 bars of LOX pressure and we are at around 31.7 liters. It seems like we're fluctuating a bit around those 32 liters.
As long as we're not using the liquid oxygen, we have the vent valve open so it can boil freely to keep it cold. opens the vent valve again. So that's how we lose a lot of locks on that account. It's of course, but that's how it is. And it's so funny to see the it's blue. You can see it's blue. Then you know it's pure locks that's coming out. It's not just water vapor. It's a pure locks. I was trying to zoom this camera, but it didn't really. It's because it's frozen.
We're going to run out of liquid oxygen. We're going to close up the valve. Over. Roger that. We're reading around 30 liters in the tank. Understood. Thanks. Shutting down.
See if it works. Yeah. Seems to work. Oh. Zoom in so people can see it much better. Configure video, camera control, and zoom. Nothing.
Attention all hands, this is flight. We have now completed the dock loading process. We can confirm that we are out of liquid oxygen, so this is what we've got to test with for the rest of the day. The dewar is empty. So that completed step number 52. Please initiate step number 53. High and low speed cameras can be initiated. Roger.
Yeah. We've got what we've got. It's the problem with the dewar car we ordered for 190 liters on a hot day, waiting 2 days, and now we haven't got any more locks.
Is in lockdown mode and we are ready to proceed to ignition.
Alastor, it is just a standard dewar car for liquid oxygen. Yes, 190 liters. So yeah.
Crowd Alpha, please repeat signal.
It's not. It's
Understood.
liquid oxygen is. The price is for we are paying 2,500 Danish kroner for 190 liters of liquid oxygen. So it's a bit expensive for us because so much of it is lost due to venting all the time, and yeah, unfortunately the Danish summer has become hot, and that's not good for liquid oxygen. So. Yeah.
Okay, attention all hands. Video report step 53 complete. We are now evacuating the two stand and preparing for hot fire. Mission out.
doing some magic with it.
Not much magic, I think it's just about faulty connection.
Yeah.
See the mouse. What is the mouse?
Say the magic words.
The C920. Okay.
If anyone out there on the live stream is in doubt, we are having a lot of cameras that are basically tired of the old age. So we need more new cameras.
Okay, this one is called Far with capital F. Let me just like this.
Far from
Let's remove it.
What did you do there?
I removed it because
You simply removed it and then you re-established
I'm gonna try to add it again.
the camera and then there's a video. Oh,
Yeah, but I think it's still frozen.
yeah, it is.
Not allowing me to configure it either.
Okay, attention all hands, attention all hands. This is flight. Data is now reconfiguring our burn parameters. We will now go back to the settings from the second burn we did. That was the one that kept the same oxidized fuel ratio, but it had way more propellant flow. So essentially we'll be pushing the engine harder than that, but that initially caused some ignition problems back on test. Ignition number 2. But anyway, we'll try it out again and see if we can push the engine a little harder this time around.
That might
Stand by
be the death of
for
this
the next
engine,
ignition.
but then we just build another one.
Yeah.
No problem.
As we always.
Always just. It's a pity we can't see the reaction. Oh, you saw something?
No, but I saw it is on a list. But it's still why?
Still frozen?
Yeah, but it's also frozen in the old image. It should not be frozen in that old image
Oh.
because it's always the same image. But let me try in a different way.
Yeah, maybe put something else in there.
Yeah, I'm gonna try to make a new one.
There's simply new ones.
I'm gonna call it Far 2.
Hot? Yes. Okay.
No, Far 2. Okay.
It would be appropriate for this test, I think, to call it fart. Ah,
Well, now you know what happened.
now the USB connection, the plug is simply fallen apart.
It's
No,
still
no, no. Drop the camera, exchange it with this one.
okay.
This is the, what is that called? That's this one. It's this one up here.
Yeah. Okay.
And we move that over there.
Okay.
Yes. Because we can't see anything.
Oh, sorry.
Oh, sorry, that's me.
Okay.
We're simply moving this away. This is not good. And this is Bianca, by the way.
time is...
Turn it a bit, maybe.
I think it's fine.
Shake it a bit.
I think it's okay.
At least we have a connection with the camera that works, and a connection that works, and this old camera, Logitech.
Hence, this is flight. We are ready to start the next ignition sequence. We might get some difficulties in igniting this one because we will be running more propellant now, but at the same OF ratio. We'll be running 80 seconds if everything goes according to plan, but the pipe might get more red this time around. At this point in time, data is authorized to engage the glow plug igniters at step 56 and move immediately to step 64, pressurization and firing at their discretion. Stand by for data's announcement. Bye now.
I'll move over here, sitting a bit better maybe.
Starting countdown at 60 seconds now.
Next to camera for the techno rave too. We can't guarantee that we can provide with techno rave each and every time we do a rocket engine test, but might be interesting to try. Yeah.
T-minus 27 seconds.
Yeah. New tests. Let's see what happens.
T-minus 15.
I'm very excited at the top right.
T-minus 5, 4, 3, 2, 1, 0.
Uh-oh. Not really igniting anything. And then suddenly it comes with a boom. What is happening?
Aborting test.
Yeah, it simply seems like it's just frozen alcohol coming out there. If it's frozen alcohol, it's because it's mixed with liquid oxygen, but hasn't happened any ignition. That's interesting. Of course, we don't know why, but of course we should be able to measure how much well, the glow plugs are changing their internal resistance. When they get hotter, the resistance becomes bigger. That means they are not running too hot for what they are used to. But if it would be interesting to measure this resistance during the test, so we can see if they actually is running some. No, measuring the amperage running through the glow plugs. All the resistance, maybe, because if the resistance is so high we can't measure it, then the glow plug is actually destroyed. We're just waiting for the data to come out, and then we can measure to see what actually happened inside the engine during these tests. We have a lot of measurings of the flow rates and so on, and we can see the temperature, we can see pressure, different places in the system, and then we can compare that with what we see and what we hear. from the test stand, and this gives a good indication of what actually was the reason why this and that happened, and what can we do to change that for another time. And I know there was a question earlier on about how much fuel we're using. Actually, it says
Pay attention all hands to the slide. We did not have an ignition on this last attempt here, and we used quite a bit of nitrogen in the process. So we are going to do another ignition attempt on this one, but we will need a little work on the test stand to try to repressurize our nitrogen system. So we'll be, let's say, 5 or 6 minutes before we try to ignite again.
okay.
Ignition out.
Yeah. Then I can.
So the situation is kind of we are shooting far left in the hydrogen system at this point. Not enough. Now we will organize the add on those systems, and we'll pressurize the two on the upside to make higher flow. In the meantime, Josh will prepare for the tank of 150 bar starter, and we will
by purpose. Thank you. Yeah. Now we try again, see what happens. At least we lost the camera, then usually it's a good sign. Annoying, but a good sign. The last chance of we have a malfunction in the ignition, but now we are just trying again and see what happens. Boom, 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 boom. Okay, they are going to do some refurbishing on the test stand because there is something wrong. I'm sorry about that, but this is how. This is what the reason why rocketry is a spectator sport. You can see on the camera, people are walking back and forth, and they're doing that repeatedly. And when they have finished that, they do it again, and yeah, very interesting. Long waiting times, and sometimes there are exciting results, and most of the time we get a good suntan and sometimes good food.
Day-to-day flight. Just be advised, we're opening the nitrogen bottle and decanting now, over.
That's okay, we have 35 bars in the pressure system.
Okay. Take a short break. Enjoy the music. could have been product placement. It isn't. It's simply just me getting lucky. Myling had a compressor refrigerator for a boat with him, filled with cold soda, so it's really nice to have in the heat. I was getting what is it called, super cold, going super cold. Just 3 minutes of heating time for the glow plug. It shouldn't be necessary, but we didn't have ignition last time, and we have an idea that the geometry of our way we have placed the glow plugs relative to the injector spray, it's not optimal. We need to do some experiments on that, and maybe another geometry of the engine itself. We are not sure, but we have to do some experiments further on. Maybe another, as I told earlier on, for those who were here, maybe with a augmented glow plug igniter, where we have a small rocket engine running very cold with a glow plug in it that ignites each and every time, but then it produces a long flame shooting out into the real rocket, the rocket engine, the combustion chamber, and ignite more a hotter fire in there. Well, let's see. Whatever happens, the glow plugs for ignition of alcohol and liquid oxygen is quite interesting, and you just have to manage the technology and see how it works. Because usually it's only used for diesel engines and for gas generators to ignite diesel fumes and with common atmospheric air, and now we are using alcohol and liquid oxygen. So we have to tweak on some of the parameters and so on, but it's an interesting technology. Thank you very much. No, I'm 5, 4, 3, 2, 1. everything is being sampled at 100 hertz, but it's still a lot of data. Yeah. Difficult to hear what they are planning, but it sounds like some kind of Frankenstein test. Is it a Frankenstein test or what?
Attention all hands, attention all hands. This is flight for an update on the last ignition attempt. It would appear that we got partial ignition, but then it flamed out, so we couldn't continue that test. So we shut it down manually. What seems to be the case is that at least for the so-called medium pressures we've been running so far, that works successfully for the remainder of the day. So at this point in time we are out of liquid oxygen on the LOX tour, so we can't add more. We have about 27 liters of it left, and we also have a significant amount of fuel left. So essentially we have decided we dial it back to, say, the medium flow range, and then so far we've set the shutdown timer for 300 seconds. So I think we're just going to run it dry.
That's nice. Okay. Kind of Frankenstein test. Yes, we are going for it. Yes, I hope you got that out on the live stream. Yeah, we don't have any more liquid oxygen to work with, and we're just trying again because we can, or because we think we can. Let's see how it goes. I think we have to go back to the drawing board and look into this engine design and see if maybe we need to do it in another fashion. So
a little bit of air out on the tanks.
one of the things we have actually discussed is opening the liquid oxygen first and fill the whole thing with oxygen, and then start up the glow plugs before entering the alcohol. But there is one problem about that. When you have full 100% oxygen in the tank and you start the glow plugs, there's nothing that can burn in there except for the glow plugs themselves, and they can burn, absolutely burn in 100% oxygen. So that is also a bit dangerous to do, not because it's dangerous, but because we can destroy our equipment totally without really knowing what will happen. So now we're just trying as the plan was. So, and then running with the glow plugs for 300 seconds or something like that. We're just running. Jacob, is it with the glow plugs running all the time or what?
So we actually shut down the glow plugs as soon as we see stable combustion.
Yeah, the stable combustion, that's
We shut down the glow plugs roughly 20-30 seconds into the run for the past 2 runs.
Yes, and then we see what happens. Yes, nice.
Countdown is running, T-minus 55 seconds.
sparks.
Minus 30.
A fast answer. We know that there's a thing that protects the thermal sensor in
Minus 20.
the engine, and it is actually a bit burned off in the at the bottom of it, and I think the rest of the sparks are coming also from that deflector for protecting.
5, 4, 3, 2, 1, 0.
That is not a stable combustion. That is just vapor coming out. Turn on the glow plugs again. Now let's see. Inconclusive. So yes, the spot. Yep. Okay.
Attention all hands, this is flight. It was a scrub on the last try here. There will be no further ignition attempts today. We are venting all tanks because somehow we can't get the ignition going again as we could earlier in the day. So there is no more live firing for today. Stand by for shutdown and cleanup procedures.
Yeah. Sådan en optag.
Ja,
oxygen coming out of this tank down there. It's a bit difficult to see, but it's beautiful. It's making a cloud of the humidity in the atmosphere is actually becoming vapor, and then if we could see it very close, it is even more beautiful, because right where the liquid oxygen is coming out, it's blue. The liquid oxygen is blue, so it's really interesting. So yeah. Jeppe, could you say something about what we have tested today and what we have tried? Because you can sit here maybe.
Yeah, I can try. Yeah. I hope you guys can see it. Hi out there, rocket fans. So I'll be talking a little bit about what we've been going through today.
And this is Jeppe. So
yeah, so you might have seen me stand over there together with Data and looking at what's coming out from the tests and how it was looking like. So today the main objective, sorry for the sound in the background, we are pressurizing the high pressure tank. The main objective today was we first of all wanted to see stable combustion, and we got to that point, so that was a huge success criteria in and by itself. Then the next step that we wanted to do is we wanted to try and push the chamber so we actually was seeing steady combustion, so the engine is sort of like in a steady state, constant pressure, constant temperatures inside of the chamber. We got to constant pressure, but the temperature was fluctuating a bit, so we tried to increase the length of the run, and that sort of worked. We got the engine up and got a little bit more stable conditions. Then the next step we wanted to do was we wanted to actually increase the flow into the engine, which is what we saw in the second last test that didn't work. And what we think might be happening is that we have the glow plugs, which is a piece of metal that has been heated up quite a bit, maybe to around 1000 degrees Celsius, and then we're shooting fuel onto it, and that causes fuel to heat up and vaporize, and then we're adding in oxygen at the same time so that it can start combusting. The problem is, we think, is that the glow plugs get cooled so fast that we get a little bit of an ignition going, and then we simply remove the heat so fast that the combustion can sustain itself. And in some of the runs, it seems like the glow plugs could get back to the point where they were hot enough, and then the engine started slowly chugging along and actually getting up and running. But here in the second last test, we sort of like probably put in so much propellant that the glow plug couldn't add enough heat for it to actually ignite. And then in the absolutely last test, we tried to go back to the parameters that we knew worked, and then this time we didn't get a successful combustion, which sort of like, at least to me, tells me that if the glow plugs is okay, they don't have any physical damage or anything, then we're probably still at the limit of sort of like where we can get the engine to run stable. We might have to look into whether or not we need to ramp up the engine more slowly with the pressures,
or maybe change the geometry of it. There's something we don't know here. Obviously there's something we don't know. Can you say anything about that? What is it? It seems we don't know exactly how to do this.
I think we have first of all the challenge of having to get the fuel into a vapor state where we can actually get it to ignite. I think that is one of the things that challenges us, and I think one of the reasons that we're having issues is that the engine seems to really start working stable when it starts getting hot.
Yeah.
So I think that the glow plugs is struggling to get the combustion going, but as soon as we get it going and we get it somewhat stable, the engine starts heating up itself and essentially becomes a huge glow plug that sustains the reaction.
Would it be an idea to heat alcohol before entering
that could be an option, but you could also argue whether you should just try to heat a larger part of the chamber. So you could put I was jokingly talking about whether or not we should actually do an induction heating of the chamber.
But maybe not.
In principle, that could also work. So there are some ideas, and we need to take a little bit closer look at the data to figure out exactly what we want to do. But for now, I'm just really happy that we got it to actually run for several seconds at a pretty much steady chamber in the combustion chamber.
was not as high as we were hoping for. I think the highest we saw in today's test was around 2.1 bars.
Okay.
And we were hoping in that particular run to get somewhere between 3 and 5 bars, so it's a little bit less than we were expecting. That could also indicate that we're not getting enough of the fuel to actually vaporize and burn inside of the chamber.
But we had choke combustion at some point.
Definitely.
And we have to look into what's happened. It seems to be the ignition that fails in the cold engine.
Yeah, I mean, for some of the burns, I think we have the ignition system running, and we're even putting in propellant for 5 or 10 seconds before we see it actually successfully igniting. So it's also possible we need larger spark plugs or glow plugs. That's also an option.
Or maybe that's talking about the geometry of the engine.
That's also
the position of the glow plugs compared to the spray pattern and so on.
Also the option that we need to actually dial back the size of the injectors that we're using, because we ran this test with the larger injectors that we had. Meaning that we might actually be at such a high mass flow that we're having trouble sustaining the combustion. So it might actually make sense to go back to other smaller oil furnace nozzles. That could also be an option actually. So that's one of the things I'll put on the test plane at least, to try and run the engine with the smaller nozzles to try and see if that helps us with the ignition part.
And well, it could also be maybe changed with start the engine with the smaller nozzles, and then when it sustains, then open for larger nozzles maybe.
It's gonna be problematic, at least on the on the log side we're actually only running with a single nozzle, so that will make it difficult.
One nozzle.
On the fuel side we have 6, but it will complicate the geometry of the injector a bit. We have to make 2 different fuel inputs.
Kind of pintle injectors or something like that.
I mean, that could be an option. It could also be an option to actually only open up maybe half of the injector initially, and then actually have like have a split injector where you're actually opening for just say half of the injector elements, and then you go into main stage to open the other half. That's also something you can do. You can actually.
Then it will also start harder because of more oxidizer in.
Yeah, more oxidizer relative to fuel. Yes, that is an option that we could explore as well. But ideally, I would like to try and keep it simple if possible.
Yeah, of course.
Now the thing is also, today it's fairly hot, up to 25 degrees or so outside. Question is, if we're having trouble igniting the engines today, would it be even worse in a winter day when the ethanol is colder than this today? That's also something we actually need to think about, because we might be launching at a cooler day than today.
But the principle with the glow plugs and the oil nozzles, burner nozzles, this seems to be so simple that it is possible to make rather simple experiments with this.
I think one of the other things that I noted that I really liked seeing today was that even when we were having trouble getting the engine to ignite, and we were actually running for quite a long time, we were not really having explosive ignitions of the engine.
No,
it was actually pretty nice transitions into having a combustion. Even though we were actually for the entire time, like 20 seconds, trying to ignite the engine with glue plugs. So
I had also expected some kind of explosions during the burn, but we didn't get that.
For the first burn with the parameters that worked best for us today, I was really several times hovering around the idea whether or not we should do the abort, because I mean I was looking at the video screen and the data feed, and I was like, come on, ignite, and it felt like forever before we actually saw a good stable ignition of the engine. We saw it like chugging a few times in the beginning, and I was like, come on. And then luckily it managed to like ignite, and that was also why I was really hesitant with calling the aborts in the last couple of runs, because we actually saw it ignite fairly late in the earlier runs. So that's why we dragged it out for as long as we actually did in those runs, because we were hoping for it to actually ignite, because we didn't want to turn them off too early.
No purple engine this time, only the
nozzle part.
So that's a good thing.
Yeah, but I also think we had more. I mean, I would also say the optimization we made with trying to reduce the volume of the lux piping made a difference today.
Yes.
We were actually talking about whether we should do the same for the fuel side as well, because it seems like we might have a bit of a gas bubble stuck in the fuel pipe as well.
Yeah, that could be. Yeah.
We can on the tubing as well.
Yeah, you can
So
see
it
that
takes
on the pressure, so,
exactly.
yeah.
So it takes a little bit longer for the fuel channel to actually taper off on the pressure sensor.
Yeah, that's a clear sign of bubbles in the system.
Exactly. So that's also something we're looking at that we could try improving.
Well, we are excited to wait. We're waiting for the data now. We are looking forward to data.
Yeah, we're gonna have to look into the data for a bit and actually see what we have. But I would say, like, compared to today's test with last time we did testing on this particular gas generator, and we're already taking a huge step forward in actually getting it to work better. So if we can do something similar next time, we are in a really good spot. So definitely the glow plugs was the right call instead of the spark plugs, in my opinion, for trying to ignite the engine.
I think so too. It's a bit of annoying that the liquid oxygen was just gassing off while we were waiting to take the test. We have got it 2 days ago.
Yeah.
And it was half full when we started the test. That's a bit annoying, but that's how it is.
Yeah,
So
I mean, everybody here would have loved to do more tests today.
Yeah,
Don't get us wrong. We would have loved to test for longer.
But
But it also requires that we have the consumables that we need.
Yes, and a larger reservoir would last for longer and keep the liquid oxygen colder for a longer time. But of course, it's also 3 times more expensive. So
Yeah, that's the thing.
yeah, that's how it is. Yes, I think this concludes the day's live stream, and then you look forward to upcoming videos about what we found out this time.
Yeah, let me know where the sparks come from. It was good.
Yeah, I think I know. You saw the tip of the.
Oh, the shield for the
shield,
temperature probe. Yeah, we burned off. We have inside the combustion chamber. I don't know if you can see my hands, but imagine you have the chamber. Then in the end, just before we have the nozzle that converges down and the flames comes out of, we have a temperature sensor sitting, and in front of that there's sort of like a flame shield that protects it a little bit from infrared radiation that is made out of metal, and that seems to have been damaged during the tests. So it's sort of like melted and probably burned a bit of it. So that's what happened.
Last time it just simply evaporated. This time it was heavier and there was more metal, but still it was hurt by the. And it was made by stainless steel. We should have made it by common construction steel. It would have lasted a bit longer.
Yeah, that's possible.
Maybe.
Also, for the guys that were actually watching, in some of the earlier tests, we had a little bit of an issue with the flames coming out of the engine and some of the close to the spark plugs or the glow plugs. We think they may have rattled a little bit loose during the testing, so that was the reason for that abort. There wasn't any particular damage to the engine that we could observe. So that was also really nice to see, even though it looked a bit hot up there for one of the burns. But overall, I would say it was a huge success today with what we saw.
Yeah, better than nothing. Not as spectacular.
And not too much of a banger, I think, would be the right.
And the live stream has enjoyed the music from the rave party over there.
I hope it's not copyrighted.
No. But it was. They have enjoyed that because it was just the background noise. So that makes it less boring to look at our videos. Yes. Are there any new interesting?
Alistair asked about the log tank. So yeah, it's a Diva tank actually. But it's one we got from our sponsor Air Liquid. So it's a standard Diva that we get 190 liters.
But we had to pay for it this time.
Fair enough.
Sorry about that, but that's how it is. There's the last question down there. Can you see that? If we are looking forward to it. Are you looking forward to the evaluation of this?
I mean, I think we did a lot of things better than last time, both testing wise, data wise. Also, I'm really happy that we actually had some live update data in the mission control, so it made it easier to evaluate what was going on. So essentially we have the data coming in with 2 seconds delay roughly from the test stand, so that helps a bit with evaluating what's going on.
We will evaluate the live stream too and see what Thank
think
you.
that
Yeah.
concludes it from my side at least today, and I'll leave you on the able hands of Scott
Thank
to
you.
handle the rest of the stream for today.
Yeah.
So have a good day, everybody.
I'll just say this concludes the day. So I'll try and find a way to close down this live stream. Right now I can actually not see my screen because the sun has come in on it. Maybe Bianca can help with this. Would you call Bianca, because I would like to close down the stream and I can't see anything. Okay, yeah. Yeah, we have a lot of people working with it. Can you help me close down this? Because I can't just shut down the screen. Do you know this? There must be some kind of